I'm always fascinated about heavy industry and what us people are capable of building and achieving with technology and motivation. A couple weeks ago, I got to speak, but more importantly, learn at the Mining Tech North America conference in Vancouver. And I'm always fascinated with heavy industries and what we're capable of. But for a technology and innovation conference, there are some dire predictions ahead if we can't fix our demand and supply problem. So let's start with demand. By 2050, the demand for copper in our digital world will exceed all that we've extracted in the last 8,000 years. While rare earth minerals are also scarce and very important to our digital futures, electrons don't move without copper, making it a foundational element for everything else and a fundamental bellwether for society and civilization as a whole. Next, let's talk about intensity. We dig some of the biggest holes in the world to find copper. The concentration or grade of this ore is steadily declining as we've mined all the easy stuff. This means to meet the future demand, we need more energy to find and extract and process the copper ore. And we're talking about tens of tons to extract ounces of copper. Now, electricity and battery technology can play a role depending on the size and location of the mine. If the mine is up on top of a mountain, this is great. We can use gravity to recharge batteries, and it does make it very feasible. However, if the mine is at a lower altitude, we lose a lot of those opportunities. Size of haul truck is also very important, but there is a scale of economy problem here, that if we put 15 tons of batteries in a haul truck, we're losing any efficiencies that we can get. Rio Tinto's using smaller trucks that do make sense with batteries, and that's a really cool innovation that I've seen. But where does this electricity come from? Typically, it's going to be burning hydrocarbons still, maybe hydroelectric if we're lucky. I think we really do need to start looking at how small modular nuclear reactors can help industries and our power demands across the world. Next is the stalling of the sector. Terry Stallman, who's a legend in the mining sector in Vancouver, explained that the economics of exploration is failing us. Big players do not do discovery, they acquire juniors. Overly bureaucratic permitting is inhibiting junior miners from being able to even look at rocks, let alone do core samples and build out a mine. This is creating a bearish capital market, further financially constraining these junior miners and inhibiting them from doing the exploration, building out, finding the resources we want, and supporting the demand of our future. Canada's business is resource extraction, and we need all levels of government to audaciously enable and invest in our futures yesterday. Now, this doesn't mean being reckless and immoral with the environment. I'm a big fan of it. I'm in it right now. But we have to recognize that if we NIMBY this to death, it's going to be outsourced to third world countries who won't have the regulations we do and create a very polluting and unethical supply of the resources that we will buy. Now let's talk about innovation, which is obviously my favorite topic within the mining sector. Mining has remained unchanged for 100 years. Incremental technological advancements have made the business of breaking rocks safer and more efficient, but they're also the first to die on the vine during volatility. We need the economical foundation to support innovation in the sector, and this will enable safer, more efficient, and ethically sourced resources. Now, last but not least, and something I've been talking about a lot, is resilience. Now, most mines operate a pit-to-port model, very similar to just-in-time manufacturing. So the pit-to-port model is very sensitive to interruption. From scooping the rocks to putting it into a haul truck, driving it out of the pit, into a crusher, down a conveyor belt, onto a train, and then onto a boat to go overseas, this careful dance happens every day. And yet, if any interruption happens to this process, it's millions of dollars of loss per hour. Technology has been integrated to increase efficiencies and maximize outputs, but can also introduce risks of interruption. Now, considering how efficient mining operations need to be economical, to be profitable, and to exist, the tolerance for these outages is low. And that means we need to build a more resilient process. Now, understanding processes and understanding where those processes could be interrupted by technology, cyber attacks, or human error, one of the best ways to understand that is conducting tabletop exercises. They're very effective, they're very low cost, and they really help organizations understand the challenges that they may face in unpredictable times. These exercises create a safe and controlled environment to test responsive strategies, identify potentially weak spots, and develop critical team coordination and muscle memory. Now, this doesn't just mean IT or bleeding edge cyber technology. It's also about understanding those processes and understanding where they could fail and creating mitigation plans. A really cool example I heard was stockpiling ore or processed material so that if there is an interruption, there isn't an interruption delivering to markets. Another additional one would be recognizing that if we're going to start using autonomous haul trucks and they stop working, how many drivers do we have to start moving those trucks when needed? In one example, they had 6 drivers and over 30 trucks. That's going to be a major interruption. So why is this so important? Well, the demand is outstripping supply, and we've stalled creating more supply to meet that demand. And because mining is a slow industry, it takes about 10 years to get a basic mine online and producing. We really don't have time to be debating this. Because if it's not farmed, it's mined.